A very good morning to one and all. I cordially invite our chief guest, Dr. Deep Singh, Honorable Director cum Vice Chancellor, ICR NDRI, Dr. Triveni Dutt, Honorable Director cum Vice Chancellor, ICR IVRI, Dr. BP Mohanty, President SVBBI, Dr. Subhashis Bhattavyar, Secretary SVBBI, Dr. Raghavendra Singh, HD, Biochemistry Division IVRI, and Dr. Manish Mahavar, Organizing Secretary SVBBI, to please occupy their seats in the dais.
apa nih Yesus थोड़ा सा वहां से नीचे रहता वहाँ का इम्प्रेशन है इसको थोड़ा डाउन नहीं उसका नीचे करें दिखता नहीं वहां से लोगों की है वहां से
Today, we have assembled at this prestigious venue for the inaugural function of 7th Annual Convention of Society of Veterinary Biochemists and Biotechnologists of India SVBBI and International Symposium on Multi-Omics to One Health, Challenges and Way Forward in Biomedical Research. Myself, Dr. Anisha VA, Scientist, Division of Pharmacology and Toxicology, IVRI. I welcome our chief guest of the day, Dr. Deep Singh, Honorable Director cum Vice Chancellor, ICR NDRI, Dr. Triveni Dutt, Honorable Director cum Vice Chancellor, ICR IVRI, Dr. BP Mohanty, President SVBBI, Dr. Subhashis Bhattavyar, Secretary SVBBI, Dr. Raghavendra Singh, HD, Biochemistry Division, IVRI, Dr. Manish Mahavar, Organizing Secretary SVBBI, all the Joint Directors, retired scientists, heads of various divisions, delegates, staff and students gathered over here to the 7th Annual Convention of SVBBI and International Symposium on Multi-Omics to One Health, Challenges and Way Forward in Biomedical Research. We are about to commence our event by lighting the lamp of knowledge and wisdom. It's my honor to invite the chief guest, Dr. Deep Singh. It's my honor to invite the chief guest, Dr. Deep Singh, and the dignitaries in the dais to come forward for lighting the lamp as we officially commence our conference. I request all the dignitaries to come forward for lighting the lamp. We express our profound gratitude to Dr. Deep Singh and all the respected persons present here who have contributed to this auspicious beginning. It's now time for us to formally commence the event. We would like to get started with the ICR song followed by the song.
जय जय कृषि परिषद भारत की, सुखद प्रतीक हरित भारत की। कृषि धन पशुधन मानव जीवन, दुग्ध मत्स्य फल यंत्र सुवर्धन। वैज्ञानिक विधि नव तकनीके, पारिस्थितिकी का संरक्षण। शस्य श्यामला छवि भारत की, जय जय कृषि परिषद भारत की। हिम प्रदेश से सागर तट तक, मरुधरती से पूर्वोत्तर तक। हर पथ पर है मित्र कृषक की, शिक्षा शोध प्रसार सकल तक। आशा स्वावलंबित भारत की, जय जय कृषि परिषद भारत की। जय जय कृषि परिषद भारत की। मानव प्रिय कृषि सहचर हित रत, जय हो पशु संस्थान। भारत के कोने कोने तक पहुँचा नव विज्ञान। 19वीं सदी प्रथमोदय, ऊना मुक्तेश्वर नव आलय। इज्जत नगर बना मुख्यालय, अभिनव अनुसंधान। बना विश्वविद्यालय, शिक्षण शोध चिकित्सा पशु संवर्धन। ग्राम अभ्युदय श्वेत क्रांति, सहयोगी शुभ वरदान। जय हो पशु संस्थान। विविध व्याधि के टीके निर्मित, रोग अनेक हुए उन्मूलित। वृंदावनी सदृश गौ विकसित, जन पोषक अभियान। मानव प्रिय कृषि सहचर हित रत, जय हो पशु संस्थान।
Today, we are fortunate to have among us, with the highly respected and esteemed presence of our chief guest, Dr. Deep Singh, Honorable Director cum Vice Chancellor ICR NDRI, with the organizing committee of SVBBI, scientists, staff and students of IVRI, extend a heartwarming welcome to you, sir, to this auspicious occasion. May I now request Dr. Trivedi Dutt, Honorable Director cum Vice Chancellor ICR IVRI, to welcome our chief guest, Dr. Deep Singh, Honorable Director cum Vice Chancellor ICR NDRI, by presenting a bouquet, please. Thank you, sir. On behalf of the organizing committee, I thank Dr. Deep Singh for providing his gracious presence to join us today. May I now request Dr. Raghavendra Singh, HD, Biochemistry Division, IVRI, to welcome Dr. Trivedi Dutt, Honorable Director cum Vice Chancellor, ICR IVRI, by presenting a bouquet, please. May I now request Dr. Manish Mahavar, Organizing Secretary, SVBBI, to welcome Dr. VP Mohanty, President, SVBBI, by presenting a bouquet, please. Thank you, sir. Once again, I request Dr. Manish Mahawar to welcome Dr. Subhashis Batabyal, Secretary SVBBI, by presenting a bouquet. Again, I request Dr. Manish Mahawar to welcome Dr. Raghavendra Singh, HD Biochemistry Division, IVRA, by presenting a bouquet. Thank you very much, sir. Now I request Dr. Manish Mahawar, Organizing Secretary, SVBBI, for the welcome address.
So very good morning to one and all. Most Honorable Director cum Vice Chancellor of this Premier Institute ICR IVRI, Dr. Triveni Dutt sir. Most Honorable Director cum Vice Chancellor of ICR NDRI and Chief Guest of the today's function, Dr. Dheer Singh sir. Most respected President SVBBI and ADG Inland Fisheries, Dr. BP Mohanty sir. Most respected Secretary SVBI, Dr. Subhashis Batabyal sir. Most respected JDs, Dr. KP Singh sir, Dr. Sanjay sir, Dr. Mendi Ratta sir, Dr. Roopsi madam, our senior superannuated faculty and the former Vice Chancellor NDRI as well as Jammu, Dr. Nagendra Sharma sir, all head of the divisions, Chief Account Officer, Senior Comptroller, Senior Administrative Officer, Dr. Koharwal, Dr. Goyal, office bearers of the SVBI, senior and fellow colleagues, personnel from the industry, participants from different parts of this country, media personnels, the senior faculty members who have joined today's function, ladies and gentlemen, and most important, the delegates who came over all over the country and overseas to attend this meeting. First of all, on the behalf of Organizing Committee SVBBI 2023, Division of Biochemistry, ICR IVRI and SVBBI, I extend warm welcome to all of you in this convention. I'm very glad to share that along with this convention, we are celebrating Golden Jubilee Year of the Division of Biochemistry, ICR IVRI. On this occasion, on the behalf of Division of Biochemistry, ICR IVRI, I welcome gracious presence of our most respected superannuated faculties, our teachers of the Division of Biochemistry, Dr. Ashok Kumar sir, Dr. Sharma sir, Joshi sir, Meena Kataria madam, Dr. Baghel, son of Dr. late Alan Singh sir, Dr. Tandon, son of Dr. H.K.L. Tandon sir, who have joined us to witness the Golden Jubilee celebration of the Division of Biochemistry. So in brief, the technical part of this meeting will start with the two Golden Jubilee oration lectures, one by Dr. Professor Vineet Singh, other by Dr. Yogesh Saini, who came all across the Atlantic from USA. I welcome both of you, sir. So there will be 6 technical sessions in this conference. We shall have lead and invited papers, oral and poster presentations. These sessions shall cover various diverse range of the topics related to biochemistry and biotechnology. So that the eminent speakers are from various institutions, including ICR, Dr. Naveen, SAUs, Dr. Manju Roy, ICMR, Dr. Chauhan, THSTI, Dr. Amit Pandey, CDRI, Dr. Chetan, IITs, Dr. Sachin, Dr. Manish, and so on. That we'll see in the due course of the meeting. I welcome all of you, sir. I'm sure that the meeting will cover abundant opportunity to interact with the expert personnel researching in various areas of biochemistry and biotechnology. So the interaction with the international delegates and industry participants shall allow us to exploring future collaboration for basic as well as translational research. So weather is relatively pleasant in the month of December in Bareilly this year. So I was actually reading in news it is like 4 degree above than the normal temperature. So I'm sure that you will enjoy technical session, interaction with the delegates, North Indian food. And I'm very confident that the organizing team shall fulfill expectations of the participants. So I welcome you all of you again. Thank you. So let us applaud for the presence of each and everyone in this house and outside. Thank you.
Thank you very much, sir, for the welcome address. Now I request Dr. Subhashis Batabyal, Secretary, SVBBI, for presenting the association report.
Good morning, everybody. On the behalf of Society of Veterinary Biochemists and Biotechnologists of India, I welcome you all. Dr. Tribini Duttji, Director cum Vice Chancellor, IVRI. Dr. Dhir Singh Ji, Director cum Vice Chancellor, ICRI NDRI. Dr. BP Mohanty, President of our society. Dr. Raghavendra Singh, HOD, Division of Veterinary Biochemistry. Dr. Manish Manahar, Organizing Secretary of the 7th Convention. All of my respected teachers present here, Dr. Joshi, Dr. Ashok Kumar Ji, Dr. Meena Kataria ma'am, Dr. Singh, Dr. Bhaskar Sharma, Dr. Mohini, Saini ma'am, and all the respected teachers, Dr. Nagendra Sharma and Singh, and all the joint directors, Dr. KP Singh Ji, Dr. Sanjay Singh Ji, Dr. Rupsi Roth ma'am. And I have seen that of my beloved friends and HODs various division of IVI and all the beloved fellow members of SVBI and all the participants who are present here from all over India and abroad. Our society started their journey in very beginning under the able leadership of late Dr. Ellen Singh sir. He is our beloved teacher. In 1995, one pre-conference meeting was held here at IVRI. You know that IVRI is the Makkah of veterinary science. Any conference, if it starts from IVRI, so it has been immense importance. But our registration, due to some technical problems, it could not be possible from Ranchi. We are supposed to register from Ranchi, but it is held under able guidance of Dr. Ellen Singh sir, Dr. Raj Prasad sir, Dr. P.C. Vishnu, and Dr. Behera. Dr. Maiti was there at the location. And first conference was held at OUAT Bhubaneswar National Symposium in 2016. And now it is our conference of international report. So I would, on the behalf of society, I would like to thanks to our Honorable Director cum Vice Chancellor, Dr. Tribini Duttji, for giving us the permission for conducting such type of conference here at IVRI. Our senior members, Dr. Sabto Sharma ji, Dr. Rajesh Nigam ji, Dr. Bande, and other members are present here. I would like to give thanks Dr. Mohini ma'am, Mohini Shaini ma'am, under her guidance, Dr. Manish, Dr. Ajay, Dr. Mukesh, and all the Dr. Praveen, the team with Dr. Gupta sir, biotechnology. They're able to conduct this type of seminar here. Actually, according to DCI, this is the National Institute, Division of Veterinary Biochemistry is here in NDRI, IVRI. This is my approach. I hear Dr. Dhir Singh is here, Director NDRI, able biochemist, renowned biochemist of India. Dr. Tribini Duttji, Director, Dr. BP Mohanty ji, ADG also, President SVBBI and ADG also, ICL. So, under your suggestions, wherever the meeting of ICAR or PCI, please suggest, please give your inputs. There should be separate and independent department of veterinary biochemistry in each and every veterinary colleges. First veterinary syllabus came under the able guidance of Dr. C.M. Singh, former director of IVRI. This was the beautiful syllabus. They are giving importance veterinary biochemistry, first year, then biotechnology course, and then clinical biochemistry course, then veterinary laboratory diagnosis. This was the excellent syllabus made under Dr. C.M. Singh, the then president of Veterinary Council. After a long gap, PCI merged veterinary biochemistry and physiology department from 2008. But some universities, vice chancellor, they made no, there should be separate veterinary biochemistry department and each and every veterinary. But some vice chancellor, they are merged. Now, with the support of all the members of biochemistry department and all the members of Veterinary Council of India, President PCI is giving, yes, from coming course, there should be separate veterinary biochemistry department in each and every veterinary colleges. I am thankful to President Veterinary Council of India, Ms. Singhji, and all the veterinary members of PCI and all the supporters who believed there should be veterinary biochemistry department, independent veterinary biochemistry department in each and every veterinary colleges. So I am thankful to all of you. In 2020 syllabus course curriculum, there will be separate veterinary biochemistry department in each and every veterinary colleges of India. Because this society, we have made that, but the upliftment of veterinary education, veterinary biochemistry, because we know in IVR I have studied from 90 to 96 here, my MBSc and PhD. I have seen almost all 75% students during their masters and PhD have taken the minor course in veterinary biochemistry. Either medicine or gynecology or physiology, nutrition, pharmacology, each and every new, they are taking minor veterinary biochemistry. Our honorable teachers, Dr. Joshi, Dr. Sharma, they're coming in the lab, Meena Kataria ma'am. Even in night 2:33, because our PCR is going on, our jail is going on, Sarah Rizlas. All the minor students, they are coming to take the help the veterinary biochemistry. Why? When we are doing our coursework, taking minor as biochemistry, why we are not giving the importance to the biochemistry people? That's why our society has built. We have raised our voice. So it is our request to all of you, because IVRI is the Makkah of veterinary sciences. Our director is here. NVRI is director is biochemistry now. So in coming future, we will get importance. The veterinary biochemistry and biochemist people, they will give the importance during the development of education. In field also, you can see in each and every state, there are biochemistry laboratory. People are doing work. They are helping the doctors for disease diagnosis part. Now, laboratory findings is very, very important for veterinary diagnosis also. Here all the professors from medicine, surgery and gynae scientists are here. For diagnosis, for if you know that if diagnosis is proper, then treatment will be better. So veterinary diagnostic part is very much important now with the treatment of disease. So this is my request to all of you. You please stay with us. And here this topic is multi-omics to One Health challenges and way forward in biomedical research. Now in these 2 days, today and tomorrow, there will be sessions. I am thankful to all the eminent speakers who have given their consent, given their speech. You convey your thoughts. We will be benefited. Our PG, PhD students, our scientists, our teachers will be benefited from your lectures. And we will send one positive message to the nation. We will give our positive message to the ICAR, ICMR, CSIR, DSIR, all these leading organizations. And this year we are celebrating our 50 years Golden Jubilee celebration. So I'm thankful to Mohim ma'am and Dr. Monish and Dr. all the divisional heads that you have taken this challenge to contribute significance of this biochemistry, and we are celebrating this 50 years of celebration of division of veterinary biochemistry, IVR. So you please come forward, and the international symposium actually what is going to happen from today, these two. So you know that our title is Multiomics to One Health Challenges and Way Forward in Biomedical Research, which reflects our society's unwavering commitment to addressing the most pressing challenges of our time. We are living in an era where the interconnectedness of human, animal, and environmental health is more evident than ever. Multiomics, as a powerful tool, holds immense promise for unlocking the secrets of disease, unraveling complex biological process, and setting a path towards a healthier future for all. Once again, I am giving my thanks to all my beloved teachers, respected teachers present here, all the organizers, members, and especially Director, Joint Director, IVRI, for giving us this opportunity for conducting this convention of Society of Veterinary Biochemists and Biotechnologists of India, days 14 and 15 of December 2023. Thank you. Thank you.
Thank you very much, sir. Now I request Dr. B.P. Mohanty, President SVBBI, for addressing the gathering.
Very good morning, ladies and gentlemen. Namaskar. Our esteemed chief guest of the function, Dr. Veer Singh, eminent biochemist and director from Vice Chancellor ICR, National Dairy Research Institute, Dev University, Karnal. Our patron, I say, our chief post also, Dr. Trivendra, the director from Vice Chancellor, ICR, Indian Veterinary Research Institute, Yatnagar. Our esteemed teachers, all the teachers present here. Dr. Subhasis Botodal, Secretary SVBBI, and all office bearers and members of the Society of Veterinary Biochemists and Biotechnologists of India. Former and present faculty members of this great institute, the research scholars, all staff members, and everybody attending this program. I'll be telling you, I'll take little, I'm giving 5 minutes time, little more, so that I can tell you about the society and all aspects, how we are grown and how what is your plannings for the future. As you know, SVBBI is a literary scientific society established for advancement of the science of veterinary biochemistry and biotechnology. To exchange and research knowledge for providing better health coverage for production, reproduction, and conservation of animals and livestock, and to improve the socio-economic status of the farmers. How this society started actually, the visionary research and scientists in field of veterinary and animal biochemistry, like to name a few, Professor L.N. Singh, Professor R.K. Srivastava, Professor R.L. Prasad, I think Professor Ashok Kumar is there, Professor Bishui, from OUTs, and many more dreamed of a platform for overall development of this subject. The first formal meeting of for the society, it took place in Ivory in 1995, and it was decided to name the society Society of Veterinary Biochemists and Biotechnologists of India, going back in 1995. However, because of some technical reasons, registration and other things were problem, and in 2008, under Society Registration Act 1960, we got the society registered in Odisha. As per the mandate of the SVBI, academic and research activities in the subject of veterinary biochemistry and biotechnology have been updated and expanded to organize a national conference and symposia for mutual sharing of advanced knowledge and annual conventions formulating the future plan of action. For Secretary Dr. Bhattal said that how it is getting difficult, and ACI we have tried for the departments, independent departments of biochemistry, because these are fundamental subjects and basic disciplines are essential to be maintained. Then subsequently, Dr. Behr and these people, they have taken the initiative, and first convention, it took place in March 2016 in Bhubaneswar. Then we had the second convention at Bangalore in 2017, third one in Hisar at 18, then next one was in Tirupati 2019, fifth one is in Mathura, that was during COVID time, it was e-conference in 2020. The last one, sixth was in Jabalpur 2022, and today we are at the IRA, and we are thankful to the Director IRA, Dr. Trivendra Kasau, to coincide with the commemoration of the 50th year of the Division of Biochemistry. He invited us, and we gladly agreed to have this convention here, and it is a great occasion. I feel excited to say, 1987 I was on this platform when I joined as a MBA student, and under pressure welcome party we are standing on this platform, and in the golden jubilee year, I get this great opportunity to be on this panel, and that will presenting my division and the society. I really feel thrilled that how this great institute has given a platform for everybody to grow, all of us. In all our annual conventions, every year felicitated the regard professors and scientists in recognition of their scientific contribution in field of teaching and research. And since 2021, to encourage the teaching and research excellence, we have 2 awards: Teacher of the Year Award and Scientist of the Year Award, since 2021. So there are many possibilities. Journey ahead of the SVBBI is filled with possibilities, and its success lies in achieving society's mission and safeguarding the professional well-being of its members. The discipline itself, like Dr. Bhattal mentioned, I want to emphasize, and it has played a big role in fighting to show that we should have a unique identity, and what is the importance for the veterinary profession. It is necessary that we should have all the basic subjects. Although hosting conventions, symposia, conference, facilitate all these things, felicitations taking place regular manner in all the conventions. There are many features planned we are going to implement. We have not done so far, and very shortly we are going to have our society website, and we will do once. Then publishing a journal, honoring members with more awards, fellowships, recognitions. These are certain things still pending to be implemented. Encourage our students. We want to also introduce several awards in name of our former biochemist eminent teachers also. And conferring fellowship, we plan to from the starting from the next convention, society will have its SVBBI fellowship also. We will start. Then coming to the theme of the symposium, multi-omics to one health. So this is the era of omics technology. When we talk about omics technology, over the page, genomics, proteomics, metabolomics, lipidomics, now genomics, all these things are related. And as a multidisciplinary research, the biochemistry subject particularly, once we take the material DNA, RNA, or protein, it is immaterial whether we are working with a plant or virus or animal or human, and all this. These are subjects like this. And they to understand the fundamental things, we need this, and it is being implemented in a big way. And that's why the theme of this symposium to cover and show that how an animal health and production management, how this can contribute. Now in this scientific deliberations over these 2 days, we'll have lead talks, invited lectures, research presentation of this. The beautiful compendium also has been brought out, putting all these things together. And this compendium is a amalgamation of current science, emerging science, new ideas and innovations for future scientific advancements. So again, I extend a warm welcome to all of you, all the delegates, everybody attending this program on behalf of the Indian Council of Biological Research, and I convey the best wishes of our Secretary there and DGISR, Himanshu Bhattacharya, and DDG Animal Science and Physicians, Dr. J.K. Janasar. On their behalf also I convey their best wishes, my personal wishes. Then coming to another point in which philosophically, SVBBI has a great future, and from where the biochemists they get their inspiration. In every year, in October, we find the Nobel Prizes are announced, and almost every year we find that one biochemist or a group of biochemists they get the coveted Nobel Prize in medicine or physiology. They are mostly biochemists. And it happens every year. So you are getting vaccine also, and every year you are getting the repeated dose also. And that provides the motivation and excitement and nostalgia to the biochemists. How much you can go, how much you can do. Many of us are excelling, but that is the limit. Every year we see fellow biochemists, whether it is from the whichever faculty, from plant or animal or microbial and whichever sector, medical biochemistry. But every year we see the biochemist gets a Nobel Prize, and that would be the level of motivation, and that's why you should be innovative and aim for excellence and nothing but excellence. With these words, once again I welcome you to this program, and our membership also, more people can join our membership and let the society grow. Jai Vigyan, Jai Bharat. Namaskar.
Thank you very much, sir, for addressing the gathering. Now, I request our chief guest, Dr. Deep Singh, Honorable Director cum Vice Chancellor, ICR NDRI, to release the compendium of the conference and then the Golden Jubilee Souvenir of Biochemistry Division, IVRI. I also request all the dignitaries in the dais to join the chief guest to release the compendium and the souvenir. Thank you all. Now, it's time to listen to our chief guest, Dr. Deep Singh, Honorable Director cum Vice Chancellor, NDRI. I take great pleasure in inviting you, sir, to address the gathering.
Very good morning. Let me apologize because of my throat problem, so I have some problem. But anyway, the most respectable, the Honorable Director and Vice Chancellor of this institute, prestigious, you can say the Makkah of the actually veterinary sciences, IVRA, Dr. Triveni. Dr. Bimal Mohanty, the president of this society, SBBP. Honorable, you can say the joint director of this very honorable person is in the hall, Dr. Nagendra Sharma, the vice chancellor of SCOS Jammu, the former director and vice chancellor of NDRI, from where actually I am now leading, the former director CIRG Magdu, and the joint director of this prestigious institute. Sir, I really happy, means it's a really flatter for me to actually be a chief guest of this institute in front of all the Dr. Subhas Mewal, Manish Mahawar, all the respected actually the faculty member, joint director, student, and ladies and gentlemen. I know two actually, I may be apologized, but I know the two biochemists here from this end in Bareilly. One is Dr. Joshi and Dr. I came to know, but I have never met Dr. Today. The one stalwart was the national professor of the biochemistry, Dr. Bhaskar Sharma. I think he's in this hall also. Because I could not see yesterday, but I just discussed with our vice chancellor yesterday. Anyway, once again, let me outset the thanks the honorable director, this honorable director and vice chancellor, Dr. Trivinda, giving me this opportunity to be invited as chief guest. I don't know whether I'm deserved or not. But one thing I would like to be share here, and this is for particularly students, that when every scientist, when he achieves something, actually, some sort of actually spirituality is coming. And I think the best example of this, you can say the Nobel Prize is single-handed Nobel Prize, win the two Nobel Prize individually. And one is science and other is peace. And that is no more than that's Dr. C. Pauling. So sometimes I also feel that's I'm here as the chief guest invited. It is a really matter of flatter to me, but not only the matter of flatter, I'm a bit surprised and destiny also. So one thing I'm going to be sharing here, all of you, because this is the Society of Veterinary Biochemistry and Biotechnology. But unfortunately, I'm not a veterinary biochemist, neither the veterinary biochemist nor the veterinary biotechnologist. But let me share, because most of you might be knowing, one of my colleagues also I would like to recognize, Dr. Aparna Mathur. We are both colleagues. We did the master from Lucknow University. So that's actually I want to be shared, because that initially I joined actually the Mathura Veterinary College. So that's why sometimes I thought, because there is a lot of discussion sometimes this veterinary and non-veterinary and this. So I consider myself as a half veterinarian, because I joined the veterinary this institute, Mathura, which is one of the best veterinary institute in India. But unfortunately, I don't know why I left after 1 month. And I joined actually the Lucknow University Biochemistry Department. After my BBSc, this Master BSc from Lucknow University. And then I joined the biochemistry. And later I never thought that I could be again into the animal science. But somehow, because I joined SCPGI in the Lucknow, but somehow I left it. And then I came to the NDRI. And since NDRI in 91, in the biochemistry department, I remain into animal biochemistry department. Fortunately, unfortunately, or you can say it is just a destiny that it leads to the highest, actually, the post of that institute, that the director and vice chancellor. So that's in that capacity I'm here. So it is also feel that it's some sort of destiny, just like otherwise I never thought that I will come back into the animal sciences. But personally, I believe science is science. There is nothing actually demarcation. And that's the topic of this today. And that is nothing with One Health. And this is also not new for us, because we might be knowing, we are telling today the One Health, one word, One Health, whatever the phrase you say. But this are also in ancient days, Vasudhaivam Kutumbakam, it is our actually slogan, which is nowadays accepted worldwide, and we are working on this. So as far as this topic is concerned, of course, it's very good of my heart. That's One Health, and that's and One Health. But this is a very, very complex process actually, because science has no boundary. Science can go to the anywhere and can be any sort of. I don't know how many you know, because in as far as this, why I'm talking about particularly related with this topic, the One Health and One World, because that's a relation. I'm not going to definition. There is a lot of course of discussion will be going on over the period of 2 days. All the topic will be covered. But you know, the science nowadays is really going to be One Health and One Health. I'm giving one simple example. The existence of the science and nature in here is one thing, that's a molecule, and that is the most century, that's a DNA. And if you look actually at the DNA and existence of this in inversion as far as human being or any, this is a reproduction. And reproduction, if you look actually as far as the eukaryotic and human being is concerned, that reproduction is going from one generation to another, and that's lying with the DNA. And DNA can be go into the next generation by only sexual reproduction in case of the human being or any virus. But today, this boundary has also gone, because it is now proven that people are studying that the DNA can be also go through a lateral entry, because no sexual reproduction is required. What I'm talking about, that what we are eating, what we are actually taking from the plant source or animal source, including the milk and meat, there is some sort of the way actually the cellular component is going inside this. So it is across the kingdom communication. It's not that the only communication, because we know that all our system is working with the all organ through endocrine system. Because I'm endocrinologist, so that's I'm just sharing it here. But now the science has been gone beyond that, that not only into the within body, the DNA works, that's a omic is. If you look at the central dogma, from the top to DNA to the metabolites, this is very complex because DNA is the most simplest one. Otherwise, if you go to transcriptomic and the metabolomic, is going to more complex. Water, please. So, why I'm talking about, because even now, if you say today, none of you may be agree that the buffalo gene or cow gene is going in our side, are the component of omics going inside our body and dictate our physiology. It was never accepted before, but today is going to happen. We also work in between that. Some of the work we have published, that milk, the buffalo gene, and particularly regulator that's called microRNA, also DNA, also mRNA, also protein. They are going from the buffalo through our stomach digestion system, and they are going to dictate our body. तो एक कहावत थी पहले, जो हरियाणा में की जो बफेलो का मिल्क पीते हैं, उनकी बुद्धि थोड़ी मोटी होती है. This could be a true nowadays. And buffalo, and that's not only this, plants also. The plant microRNA and plant this gene also going in our body, and they are dictating us. So the topic of this particular symposia, what is really very relevant. And this is but very cautious. We have to be very cautious. This is very, because as far as most of the omic, except the genomic, they are very, very dynamic. Even if I'm speaking today, right now, actually the cellular component of the RNA and the metabolite is not be different. And if we are sitting actually this. So how this dynamic process is going to be, because throughout my 20 years, I work only on transcriptomics, and particularly in the functional genomics. And this is so complex actually, I don't know, because I would like to share one thing. This all biology after DNA discovery started with the Human Genome Project. One of the most ambitious project actually in the world. And even United States do not have the actually fund that time. And they approached to the Congress, just like you might be knowing United States into the United States system. The Congress is the bigger house, upper house, and they approached to get the fund from that, because none of the scientific departments has that much fund to to tackle the actually human genome project. But the human genome project, because of the, you can say, the branch discovery of a sequencer, they come into the actually before the time they completed. And what was the estimated time? But there is a second part of the human genome. Most of us, we do not know. That is called ENCODE project. That nothing, it is encyclopedia of DNA. And today, till today, we do not know. Very teeny amount actually of the DNA we know how it works, how it is function. Because how a particular, most of the gene has been now identified in case of human, how is regulated. But as far as animal science is concerned, I think we know very less. Let me, one example, how I can say, because in the production, I belong to the production. So the one particular, one specific enzyme, gene, that's called aromatase, we encode actually the aromatase enzyme, which is actually involved into the estrogen biosynthesis. And estrogen is very, very important as far as fertility is concerned, and not only in the human, but into across. Not a single amino acid variation into the amino acid of the buffalo, cattle, fish, or human. Exactly same enzyme is regulating. But when I work actually into this, human also working in the same, that's FS is going to be regulated. But very few people know the regulation part of the buffalo and bovine is very different as compared to the human being, because the transcription factor which regulate this particular aromatase buffalo is different, but the signal is the same. That's why no one has pointed out actually. That's we discovered actually, and a lot of actually people have been. And that's SNP, if you do not know. So what I'm actually wanted to talk about, the ENCODE project is really very, very difficult. And if you come into the omics project, is again a very complex process. So we have to be through this symposia. I would request all actually the president as well as all the distinguished biochemistry here. Please be cautious actually, otherwise sometimes the more complex process. But as far as livestock is concerned, being a biochemist also, now we're actually joining as director of this National Institute, they're very prestigious. Reason is that because, of course, there is two. The backbone as far Bareilly and this IVRI as well as NDRI, they are backbone for the livestock research. One is for the health, another is for production side. But that, you know, as far as livestock is concerned, total wealth of GVA of India is approximately 14 lakh crore. Out of 14 lakh crore is only 10 lakh crore is coming from dairy sector. But the most problem as far as this dairy production system is concerned, up 10 lakh GVA, you can say contribution into the GDP, is by the two important aspects. One is health, another is feed and fodder. I think we should very simply work in such a way that this production system should be enhanced, irrespective of the omics and understanding. Need of our is today that we have to be very classically, if you are going to be working into omics and genomics and into the metabolomics, please, because there is a really need. This three system in India is till today, for the plant science, they have developed a phenomics system. But in animal science, livestock center, there is no phenomics center. Until unless you could not understand actually the metabolomic is going to be happen, what type of actually the genetic component is going to be released into, you cannot actually go for this. Because in the NDRI, if you look at it, 2050 vision, we made actually, and that time I also proposed. Now I think the beauty of that actually the period of this time is not to, we have to be work in integration to be improve our production system and actually at the economic value of through livestock. Very simplified way that we have to be developed, not only the production, but at the same time, because of invent of this actually a high-end science, we can also actually go for as far as the production system toward economy. Reason is that if we make the only simple phenomic, actually the center into the livestock sector, that's we submit a 150 crore project actually to DADF recently. Another actually DADF has already, because of NDRA research, they have invested 270 crore across the India and developed a 30 center for the multiplication of the germ blast and multiplication of animal. There is a lot of entrepreneur actually, and the businessman is looking forward to develop a cattle herd, but they are not getting a good quality germ blast. Still there is a average of our nation average of livestock in milk and cattle and buffalo is not actually very pathetic, I will say. It is for 3 and 4 liter per animal. But of course, it is not that only animal is actually increasing production. If you go back, actually, or look at our history, from our after independence, our milk production is increased 1200%, 1200 times. But the animal production is only increased by 6% and 1200% milk production. This cannot be because of animal. It is only because of the technology intervention. But still there we have to go for a very long way to make, and that's why our economy is not, as far as livestock sector is not becoming. Another is the health sector. But as far as this is concerned, not only our production and livestock, but also very close relation with the human being. So genetic diseases and other so many actually the important part. We have to be work and we have to be work together. So I think this type of this particular conference going to be a give long way message actually. And but I request that we should have it, just like Dr. Bimal Bhavanti is telling, most of the novel written by biochemists, but that's our also responsibility. We have to keep something which can be a very, very executable. We have to be a recommendation that we have to be executable, not that so much complex. If we go here, the omics, it will become difficult because leaders need actually, if you go to the earlier when I was a young scientist, we was thinking actually the leaders need actually, I don't know, they don't know what is the gene and that's, no, now I'm wrong actually. The leader knows actually very specific things. And that's actually we should also, each and our researcher, student, should start our project with the economic value of the project. And they have it, this is the right time when the biochemist and any discipline student, if you make actually your project in such a way that which can lead to the some sort of technology, that's not very difficult. It could be a small technology, could be big technology, or could be lead to the actually big technology. They can be entered into the, as far as entrepreneur is concerned, because today is the time for entrepreneurs. India is developing more than 10, 20 technologies and commercializing every year. And they are very small technology and that's visibility. Where we are working in genomics is also very important. But we should also look for the technology and look for the actually the of the nation, what is the immediate need of the nation, and we should work together. So I would request from the president of the society, all the speakers as well as all the actually we should develop a very specific crisp as far as this executable points which can be. I think why not actually we should develop because still we do not have a genomic center in animal system. If the NDRI and Bareilly is not going to be taking a lead, who is going to be taken in India? So these are some of the important flagship programs we should start it. And then because this genomic center is not only give it up toward production, but also actually taking the what type of animal disease, which will develop a very, very sophisticated as a diagnostic is concerned, because disease animal metabolite is different as far as the normal animal. Simple, most economic actually, this disease in case of production, that is mastitis. Still we are struggling with this mastitis. There is a lot of problem. I don't know how much, because this mastitic animal in our country, if it is not going to be regulated, what effect is going to be in human health in the era of actually omics, and particularly the term which is called lateral gene transfer through microvesicles. That is established, that called MC, this microvesicle, secreted from cell, goes to the circulation, and they can go through a body, out of the body through milk and meat, and they can crosstalk with the human being. And similarly, the plant, even fungi is talking us, even actually the rice is talking about that. A lot of actually microvesicle has been isolated from rice and fungus, and they are how they actually talking with this human being, animals. It just need to be studied as nowadays. I think this is it. Once again, thanks, Dr. Triveni, the Honorable Director and Vice Chancellor, for giving me the opportunity and share some of the views. And this is some problem. I may be sorry for that, because the biochemists generally talk about some very basic biochemist and molecular biology. But you remember this. Of course, the biochemistry is not one subject. It is a bio and chemistry, if it's a biological chemistry. So everything, all kingdom, whether the plant and the animal or human being, is the biochemist. The biochemistry is not very difficult. I don't know what is the Krebs cycle is different from buffalo. No, there is no glycolysis different from, and that is one revolution has been done and by the biochemist that this cancer, all the cancer cell has a lactate production entire, and that's become every cancer cell. So it's small research and discovery which is going to be leading to the actually the technology can be come out by the biochemistry. But I think anatomy is also biochemistry. It is not that anatomy is and pathology is not, a physiology is not biochemistry. If you go into the deep, you have to be deep. So everyone has a role. It is not that the biochemistry, but every subject has the great and we should respect together. So with this, once again, thank you for giving me opportunity to share this galaxy of the scientists of this particular session. I'm really flattered, very honored that I get this opportunity where this all the distinguished biochemist and the stalwart like Dr. Nagendra Sharma Sari is there. And sometimes I feel this is a really very means difficult or sometimes feel actually get the opportunity to in front of, but this is the cycle actually, the life cycle. We have to be retired, another person has to become. Thank you very much.
Thank you very much, sir. We are truly grateful for sharing your valuable insights. May I now request Honorable Director cum Vice Chancellor ICR IVRI, Dr. Triveni Dutt, to felicitate Dr. Dheer Singh, Honorable Director cum Vice Chancellor ICR NDRI. Thank you, sir. May I now request Dr. Raghavendra Singh, HD, Biochemistry Division, IVRI, to felicitate Dr. Triveni Dutt, Honorable Director cum Vice Chancellor, IVRI. Thank you, sir. May I now request Dr. Manish Mahavar, Organizing Secretary, to felicitate Dr. BP Mohanty, President, SVBBI. Thank you, sir. I once again request Dr. Manish Mahavar to felicitate Dr. Subhashish Battabial, Secretary, SVBBI. Thank you, sir. May I now request our Honorable Director cum Vice Chancellor IVRI, Dr. Triveni Dutt, for addressing the gathering.
A very good morning to all of you. Dr. Dhir Singh, Honorable Director and Vice Chancellor of National Dairy Research Institute, Karnal, Chief Guest of today's program, Dr. B.P. Mohanty, Honorable President of the Society, and Honorable ADG also, Dr. Subhasis Batwal, Secretary of the Society, Dr. Raghavendra Singh, Head of Division of Veterinary Biochemistry, Dr. Manish Mahawar, Organizing Secretary of this very important National Convention and International Seminar, Professor Nagin Sharma ji, Honorable Director CIRG, former Director CIRG, former Director NDRI Karnal, and former VC Jammu Veterinary University, esteemed Joint Director colleagues of IVRI, distinguished Head of Divisions of IVRI, the great biochemist, Dr. Bhaskar Sharma ji, former national professor, Dr. Ashok Kumar ji, Dr. Joshi ji, senior officials of IVRI, esteemed delegates from the various parts of the country and also the overseas country. Indeed, it is a great pleasure for me to welcome all our honored delegates in this very important 7th annual convention of the Society and International Symposium on Multi-Omics to One Health, Challenges and the Way Forward in Biomedical Research. I welcome you all in a very important and premier Institute of Veterinary Science. This is the oldest institutes in Indian Council of Agriculture Research. These institutes have been established 130 years ago. We have completed 133 years. Recently, we have all organized 134 our foundation day. This is the institute where responsible for eradication of various deadly diseases like rinderpest, African heart sickness, Dohirine, CVBP. So we have a significant achievement in our hands. If we see the research impact of this very important institute, this institute have completed 133 years, and that too we have a full-fledged 6 joint directorate and full-fledged 47 divisions and sections. We have developed more than 50 life-saving vaccines, diagnostics, and therapeutics. We are the institute who are regularly giving technical backstopping to our national animal disease control programs. The quality control of the vaccines, veterinary biologicals, is also the responsibility of IVRI. Whatever the vaccines imported, developed, are newly used in the field, these vaccines are to be tested first at this very institute, then only vaccine can be used. This institute is also responsible for giving a health backup to all the zoos, safaris, and rescue center of the country. we have 95 patents in our hand. And also we have also commercialized 50 technologies to 150 commercial houses, including 10 important vaccines. Whatever the vaccines used in our national animal disease control programs, these vaccines have been developed by the scientists of this institute only. So we have a very long legacy, and if we see our 4 vaccines, name of the 4 vaccines, like our Brucella cotton strain 19, oatpox, classical swine fever, these are the vaccines, and PPR, these are the vaccines who are responsible for saving 8,500 crore in a year. So these are the our milestones, and this is the opportunity for me. So I shared the brief profile of the institute. And you see, this is the appropriate time for organizing this very important national convention and international seminar. We have also scheduled some of the important seminars of the core disciplines at this institute during this month. Why this is appropriate time? Because recently Honorable PM have launched a very important programs, the Viksit Bharat, how we can transform our developed country in develop into the Viksit Bharat. So this is one of the Viksit Bharat target to be achieved by 2047, and other important target we are to be achieved by 2025, making this Indian economy between of $5 trillion. So currently we are already at $3.75 trillion economy, but we have to reach to $5 trillion economy by 2025. We are also on the way making the vision roadmap for 2035 and 2047. So these are the very important activities. We are already into it. So this very important convention and seminar will really play a greater role in making the roadmap of the livestock sector. The responsibility have been given to IVRI and NDRI making this the roadmap vision for 2035 and 2047. So you see, achieving 5 trillion the Indian economy, we must have $1 trillion economy from the agriculture and allied sector. Achieving this $1 trillion economy by 2025, this sector must grow approximately 17% annually. Currently, it is only 10.75. So you see, this is the target has been given by the present government. So we have to work very hard, moving ahead as per the directions of the government and the expectations of the council. So this important seminar will really play a greater role for all of us. I am really grateful to the society for hosting this seminar and choosing this institute as a venue for organizing this international seminar. And I am also grateful to the whole team of biochemists who they have worked day and night. They are also celebrating the Golden Jubilee celebrations. This department have already completed their 50 years of eventful journey. So we are really grateful to all the previous biochemists and also the biochemists working currently. in the department. So you see, the we have been asked to give the target of next 5 years. So we have already prepared our target of next 5 years, how a total of number of 171 technologies has to be developed by this institute, and including the important 22 vaccines. And out of these 22 vaccines, 10 vaccines are really related to the important national animal disease control programs. These vaccines are related to the marker vaccines and thermostable vaccines. These two important vaccines, thermostable vaccines, FMD and thermostable vaccine PPR, and marker vaccine FMD and marker vaccine PPR, these vaccines will be required in near future. Once we will be at a eradication phase of these two important. So we have a great role in controlling the important diseases of the livestock. And as far as this conference and international convention, international seminar is concerned, this topic is very important nowadays. This omics, this can really help us to identify potential genetic threats by studying the genetic makeup of pathogen, understanding their transmission dynamics, and also addressing the risk factor associated with their spread. So these are in this context, this is very important for all of us. And Division of Biochemistry is celebrating its Golden Jubilee celebrations. And you see, this division is a very important division of IVRI. And we are really grateful our earlier predecessor directors and also the biochemist who thought establishing this very important division. We are moving ahead as per the National Education Policy 2020. And in the National Education Policy, the relevance of basic science have been described greatly. So in near future, we have to establish a separate college of basic science and in the tune of National Education Policy 2020. This in tune of National Education Policy, we have already initiated PTech biotechnology from this very academic session 2023 and 24. And in this year, we have tried hard to initiate the UG in biochemistry, but we could not start because of some of our limitations. But we are committed to initiate this UG courses in biochemistry from the next academic session. So you see, this is the directions of the National Education Policy, that we have to move forward, making our education multidisciplinary, not only the higher educations, but undergraduate education also. And we have to make our education flexible and holistic. So making education flexible and holistic, these very basic disciplines are greatly important. So we are committed to initiate undergraduate programs in biochemistry from next academic year. We have already initiated MBA in veterinary business from this academic year. So you see, making because you see, now the single stream education will be phased out over time. And there should not be deemed university status also in future. We have to transform this deemed university status into the multidisciplinary education and research university, MERU, and we have to make this MERU into the globally competitive university. Making globally competitive university, we need international collaborations. Without making international collaborations, this component will not be feasible. And you see, we have to develop international network. We have to develop world-class infrastructure. And also, we need to enhance our digital education. And we have to make greatly our community connect, also making this whole university into the globally competitive university. So these conferences will not only help us making the future roadmap, but also these conferences will also help greatly to all of us making a greater collaborations in teaching and research and outreach activities. So this should be our vision. Whenever we are organizing these type of conferences, we must have our target in behind, how this target can be achieved. This biochemistry division have been created during 4th 5-year plan as a division of physiology and pharmacology. Why I am telling this event of history? Because this is the time when our biochemistry division organizing the golden jubilee celebration. We must remember our this previous history, our previous achievement, our previous stalwarts who have contributed significantly, making this whole biochemistry division up to this stage. So you see, this postgraduate education leading to master in veterinary science in biochemistry was initiated in 1971. Independently, this department started mid-1972. So this department having a full-fledged the status of biochemistry and food science from the mid-1975, and the mandate we know this department is to impart postgraduate education in biochemistry and conduct research in the areas of animal health, production, and technology. This is the only division wherein we have a largest number of students. I would like to just figure some of the statistics that this division, how this division have contributed supporting our deemed university education. So during the 5-year plan, this division has started with 6 labs only. And now currently they have also added in their dimensions 3 more labs. Also. Now currently there 9 important labs. This department is the important labs are like you see genetic engineering lab, they have also added, and nutritional biochemistry, and also immunochemistry. These are the 3 labs they have added into the previous 6 labs. And we have a full-fledged center interventional facility under this biochemistry, and tissue culture lab, and we have also developed recently the postgraduate practical lab. This is the only division wherein this biochemical profile of water buffalo was reported for the first time in the country. So this why we are really grateful to our earlier scientists who have worked greatly in this very important division. The later years, the main focus of this whole division was the clinical biochemistry, reproductive biochemistry, host pathogen biology, biochemical toxicology, cancer biochemistry, membrane biochemistry, and disease diagnosis. These were this later on they have added some of the areas. And currently, the main focus and the project which our scientists are handling are related to the host pathogen interaction. A special reference to cancer biology, lipid metabolics, and computational biotechnology, biochemistry. So these are the newer areas they have added into their dimensions. And as far as the whole this dynamics of biochemistry in relation to the our faculty, teacher, students, and our international training programs is concerned, a total number of, you see, 50 scientists worked in this very important discipline. 50 scientists till now. Currently, 16 scientists. Earlier, our honorable superannuated scientists, 34 scientists, they have worked earlier in this discipline. And you see, around a total number of 270 students have been exposed by this discipline in major discipline of biochemistry. So I am not talking of the minor. Minor is a very large number. But you see, around 270 master and PhD degree have been awarded. And I think currently 24 are going to award. So this the, you see, dynamics of the student from this discipline. And a total number of 69 projects they have handled, 78 projects they have handled till now, and including 17 international projects. They have also, this is the only department wherein a series of international training were organized. A total number of 15 trainings they have organized, international trainings. And as far as this publication portfolio of this department is concerned, very rich. They have published 440 plus publications, including 225 publications in international journals. So you see, this is the publication profile of the division only. The student or scientist '86. And our 20 alumni, they are pursuing their career in various overseas countries. So you see, the one important attributes of national education policy is to connect with the alumni regularly. And you see, not they have already fixed that twice in a year we must connect our alumni regularly. So this is our target, that how best, not only of this discipline, but that all our 19 disciplines, how we can connect our alumni in order to enhance the visibility of the institute and also tap the grants for various R&D activities. So this is our target, also plan. And this is the department, the choice for all the student related to the health disciplines, or some disciplines of production disciplines also. Almost all disciplines, they choose the first choice to choose as a minor the biochemistry. So biochemistry department has a great role in these educational activities of deemed university. So we are really grateful to all the biochemists served earlier and serving currently. So we should also expect future also such kind of innovation, such kind of participations and collaborations in the teaching, not only in teaching, but research activity will keep on continuing. So around 85 students per year they are taking as a minor of this biochemistry division, and 30 students the BBSC, now currently 55 students regularly they are taking classes from biochemistry, and on an average there is a 36 credit load on this discipline. So you see now the basic science will play a greater role in coming days. We are also thinking that how the separate college of basic science can be established. We have already given our the proposal of establishing this whole deemed university into the globally competitive university to the council, and partly they have also allocated money making this proposal through. So we are really grateful to council also for supporting our education facility. Now you see, in tune of national education policy, not only of this IVRI, but the all the deemed university, the priority is the university. How this university can be transformed into the multidisciplinary research and education university. And this is our target. And you see, the last I extend my a warm welcome to all the delegates and alumni from various corners of the country. And also, I have also seeing that some of our overseas alumni, they have also witnessed their presence at this very important SVBBI 23 programs. And I hope that this conference will not only provide the opportunity to identify and design the roadmap of you see, research programs in our country, but also will create a greater platforms making a international collaborations in various R&D activities. I wish all the participants and organizing committee a great success at this SBVI 2023. Thank you very much. A very, very happy New Year. Thank you very much.
Thank you very much, sir, for addressing the gathering and for your valuable words. Now, we will have the Golden Jubilee Oration Lectures. I kindly request all the dignitaries on the dais to please be seated in the front row of auditorium for arranging the stage for the lectures. I request Dr. Manish Mahavar to please accompany the dignitaries to the respective seats.
जी ये जाना पड़ेगा अनुराग जी।
इसको डायरेक्ट कर दो।
सभी
lecture.
लोग नीचे तो पहले लोग से बात बस
I request our director, Dr. Trivenidar, Dr. Deep Singh, Dr. Subhashish Patabial, and Dr. Manish Mahavar to occupy their seats in the dais for the Golden Jubilee lectures. Our first speaker is Dr. Yogesh Saini, Professor of Population Health and Pathobiology, College of Veterinary Medicine, North Carolina State University. The title of the presentation is The Multi-Omics Approach to Identify Molecular Pathways of Environmental Lung Diseases.
So let's start this session.
Yes.
There is a minor change in the schedule of the lecture. Our first speaker is Dr. Vineet K. Singh, Professor of Microbiology, Hicks-Valley College of Osteopathic Medicine, A.T. University of Health Sciences, United States. He'll be talking about physiological and clinical significance of membrane branch chain fatty acids in the bacterium Staphylococcus aureus. Now, I would like to welcome Dr. Vineet K. Singh for the lecture.
Well, thank you for this opportunity. It's truly an honor to be here, seeing my professors who guided my career, seeing all my senior friends, my colleagues, and people who followed me in very accomplished positions. So, I will take this opportunity to share some of the research projects that I have done in my lab. I will talk about one of the research project. I've given some talks in the past at IVRI, but this is something that is new. I have never shared this project with you. So I was trained as a biochemist here, and a biochemist is a biochemist for life. Now I'm in microbiology department. I work with the bacterium Staphylococcus aureus. For me, it's just a bacterial cell, and there are lots of biochemical reactions that occurs. So I'm still a biochemist, although I teach microbiology that I never studied as a student. So I don't really think that Staph aureus needs much of an introduction. If I collect samples from your nose, I'm very positive that about 40% of you are carrying this bacterium in your nose, maybe in other moist skin areas. It's a major human pathogen, but it's really not a major concern as long as our immune system is working the way it should work. But if there is a weakening of the immune system, and there are so many regions that people are immunocompromised these days. They are on steroid therapy because of the organ transplant. They have immune disorders, so they are on steroids. A lot of people are HIV positive and they do not have access to or limited access to antiretroviral therapy. A lot of people who had COVID, serious COVID disease, they recovered from it, but they never regained that immune resistance. So Staph aureus, anytime you see, like, as I said, that 40% people in the community, and almost everyone, every physician, every nurse, everyone who works in the hospitals, they are colonized with Staph aureus. And once there is a weakening of the immune response, maybe our hygiene is compromised. You see like a lot of these skin infections, where you see like tight erythematous skin, some purulence building, like pus being generated. About 80% of these skin infections are caused by Staph aureus. And when this bacterium gets deeper into the body tissues, if it gets into the blood circulation, gets into the bones, gets into the joint tissues, especially when it is in the blood circulation, none of the organ system in the human body is off limit. It can cause like some very destructive pathology, disease in almost like any of those organ systems. Now, when it comes to the clinicians, how to cure these infections, that's a challenge because most of these Staph aureus infections that cause disease these days, they are resistant to most commonly used antibiotics. So when you think about the microbial pathogens, they're not always in the human body. Once they are outside of the human body, their life is very rough. They are faced with like fluctuating temperatures, extremes of acidic and alkaline conditions, nutrient limitations. Even when they get into the human body, they have to be dealt with like the immune response. The clinicians try to cure these infections by using antibiotics. So the life of the microbial pathogens is fairly rough. So one of the things that like the old Indian Chinese medicine is to prevent from the infections from occurring, prevent the disease from occurring, because prevention is better than curing a disease. So one of the things is like what we can do to minimize the presence of these bacteria in the environment so the transmission can be restricted. So I got interested in like the membrane properties of this bacterium. And membrane is very important. When these bacteria, they are outside of the human body, the membrane has to be fluid. If the membrane is not fluid, if this membrane is not fluid, then the cells will die. This fluidity is important for the nutrients to get in and any of the toxic metabolic end products to be expelled from the cell. And we have seen that anything that contains mostly these saturated fatty acids, for example, the animal fat, it freezes. It becomes solid at room temperature. And we also know that the membranes are mostly phospholipids. So if those phospholipids contain mostly these saturated fatty acids, those membranes will freeze. And once the membrane freezes, those cells are going to die. So the bacterial cells like Staph aureus that spends quite a bit of its time outside of the human body, outside of an animal body, what it does to keep that membrane fluid, it alters the phospholipid composition. So what it does is it makes like a lot of unsaturated fatty acids, like this one. It also makes some branch chain fatty acids. So when the membranes contain these unsaturated fatty acids, these branch chain fatty acids, that hinders the tight packing of the membranes like this. Now you have a membrane here, the tight packing of the membranes are inhibited, and now the membrane can remain fluid. My next goal was to figure out how these branch chain fatty acids are synthesized. And there is so much literature available how these branch chain fatty acids are synthesized. The synthesis of branch chain fatty acid starts with the branch chain amino acids, leucine, isoleucine, and valine. Those branch chain amino acids are deaminated. Once they are deaminated, then an enzyme, branch chain alpha ketoacid dehydrogenase, basically converts those deaminated branch chain amino acids into short chain carboxylic acid. And then the enzymes that are involved in the elongation of these fatty acids, they come into play, and then they synthesize these branch chain fatty acids of different carbon lengths. Now, in these branch chain fatty acids, there are two types. One is iso, that you see here, the iso and anti-iso fatty acids. The iso fatty acids are the branching that occurs on the terminal carbon. The anti-iso is when the branching occurs at the penultimate carbon. So based on the literature that was available in 2007, 2008, I identified the genes in the bacterial chromosome, Staph aureus chromosome, that are responsible for making this BKD enzyme. The BKD enzyme is a 4-polypeptide enzyme. And those 4 genes that code for these 4 polypeptides, they are clustered together. So they are like a polycistronic message that are generated. They are translated, and then these 4 polypeptides come together to make a functional BKD enzyme. So my goal was to create a Staph aureus that does not make this enzyme. And to do so, what I did was I disrupted the first coding region. So now I was generating a dysfunctional polypeptide, means a dysfunctional BKD enzyme. I also created a complemented strain. So once I was able to generate this BKD deficient strain, I put this BKD gene cluster on a plasmid in that deficient strain, which is called complemented strain. So now I started doing some biochemical studies. My first study was to figure out what is the composition of the fatty acids in the membranes of these 3 different strains. Now, this is very crowded slide, so I will skip. This is basically like the composition of different fatty acids in the biological membrane of those 3 different strains. So let's take the take-home message. So what you see here is, like, this is the wild type Staph aureus. The straight chain fatty acid is only about 32%. The branch chain fatty acid is 64%. And when you further segment, like the anti-iso and iso fatty acids, anti-iso is 37.6%. These are the anti-iso fatty acids that are generated from isoleucine. In our BKD deficient strain, now you see like that branch chain fatty acid drops from 64% to 35%. And when you look at the complemented strain, it's back to very much to the level of wild type. So now we were able to create a strain that was lower in the presence of branch chain fatty acids. So then we try to determine what impact it has on the growth of Staph aureus. So in this graph, what you see, like these are the mutant strains, BKD deficient Staph aureus strains. As you started lowering the temperature, the BKD deficient strain, it started slowing its growth. At 12 degrees Celsius, it stops growing. Now, this one is again very crowded. The take-home message from this is that the BKD deficient strain will not grow at very low temperatures until you add those short chain carboxylic acid that are the products of the BKD enzyme. We also studied the effect of those reductions in the branch chain fatty acids in the membrane. Now Staph aureus could not grow in the presence of like alkaline conditions, in the presence of hydrogen peroxide, or in the presence of toluene. So now this BKD deficient strain that was making less of the branch chain fatty acids in its membrane, it was fairly sensitive to the conditions in the environment. Then we checked what happens when you expose these bacteria to the human lung epithelial cells. In those in vitro studies, what we found was that the BKD deficient strain that you see here in the darker bars, these BKD deficient strains were very compromised in its ability to adhere or bind to the human lung epithelial cells. And that binding is very critical when the bacteria that get into the human body to establish an infection. We also put these BKD deficient and BKD plus strains into mouse tissues. We infected mice. And what we found was that as the infection progressed, the BKD deficient strains, they showed like very poor survival in mouse tissues like liver and spleen. So what we found was that the BKD enzyme, when it is not being expressed in Staph aureus, it was making reduced amount of branch chain fatty acids. But it was not completely eliminated. It was making still some branch chain fatty acids. And even with that reduction in branch chain fatty acids, Staph aureus was susceptible to so many different conditions. So when we tried to publish this paper, the reviewers asked, okay, fine, you basically inactivated BKD, but what is the source of those branch chain fatty acids in your mutant strain? So we started looking into the dark. What we did was we just searched for anything that was similar to BKD. And we found out that there were actually 2 enzymes one pyruvate dehydrogenase that is also like a multimeric enzyme, just like PKD, 4 polypeptides. And the genes encoding those 4 polypeptides are very similar to the 4 polypeptides of BKD. And pyruvate dehydrogenase, as you know, that it converts pyruvate into acetyl coenzyme A that enters into the Krebs cycle. Another enzyme, alpha ketoglutarate dehydrogenase, that is actually part of the Krebs cycle, which has 3 subunits in Staph aureus, and 2 of those subunits are very similar to BKD and PDH enzymes. So we started thinking maybe these 2 enzymes somehow play a role in branch and fatty acid synthesis in Staph aureus. So we created strains that were deficient in pyruvate dehydrogenase, deficient in alpha ketoglutarate dehydrogenase. Just look at this last column. That tells you, now this time you will see like the branch and fatty acid level is different because we used a different strain of Staph aureus, a methicillin-resistant strain of Staph aureus USA 300, that is the most prevalent Staph aureus methicillin-resistant strain in the United States. You can see inactivation of BKD drops this BCFA level from 50 to 30%. Inactivation of KGDH has no effect on branch and fatty acid, but inactivation of pyruvate dehydrogenase added another complexity in the research project. When you do not have pyruvate dehydrogenase, now Staph aureus was making 80% branch and fatty acids. We also tried to measure the membrane fluidity of all these BKD, pyruvate dehydrogenase, KGDS deficient strains. So the dark gray bar is actually showing you the membrane fluidity that is determined by measuring the membrane polarization values. You basically incubate the cells with a fluorescent dye, and then you measure the polarization values. Higher the polarization value, lower is the membrane fluidity. So this is the wild type strain that has the functional BKD enzyme. So this is the BKD mutant. You see like higher polarization means more rigid membrane. A pyruvate dehydrogenase that makes very little, like very high branch and fatty acids, has very fluid membrane. The yellow bar basically is the level of carotenoids, staphyloxanthin. Staphylococcus aureus is the full name for a region. Aureus means gold. When you culture these bacteria on nutrient agar, they produce golden colored colonies. And that golden color is because of staphyloxanthin. Staphyloxanthin is more like cholesterol. So our assumption was that when you are making less branch and fatty acids in this BKD deficient strain, very rigid membrane, it was making more of those staphyloxanthin, maybe to stabilize those membranes. When you have a deficiency of pyruvate dehydrogenase, you do not see much of that golden color. And the reason why you do not see that golden color, because if you recall cholesterol, what do you need for the synthesis of cholesterol? You need acetyl coenzyme A. When you do not have pyruvate dehydrogenase, what you're missing is the conversion of pyruvate into acetyl coenzyme A. So there is a limited pool of acetyl coenzyme A, so that's why you are making less of that staphyloxanthin. So the question that we had, what is responsible for those branch and fatty acids in our BKD deficient strain? We still did not get an answer. So at this point, we started thinking maybe the media that we are using, trypticase soya broth or brain heart infusion, had those short chain carboxylic acids. And remember, if they are present, these short chain carboxylic acid, you do not really need BKD enzyme. So to prove our point, what we did was we cultured Staph aureus with BKD or without BKD in very defined media, where we knew every chemical constituent that did not contain any of those short chain carboxylic acids. When we use that defined media, what we found was that the wild type strain with a functional BKD could grow. But the mutant strain, BKD deficient strain, could not grow in this defined media until we added those short chain carboxylic acid. This provided the clue that BKD is the only enzyme that is directly responsible for the synthesis of branch chain fatty acids in Staph aureus. We also found during this time that in the BKD deficient strain, this two-component regulatory system that is responsible for, not for the synthesis, but for the excretion of all those 3 dozens of very potent toxins that are produced by Staph aureus. So they are synthesized, but bacteria cannot excrete if this two-component regulatory system is not functioning. In our BKD deficient strain that you see here, we found no activity with this two-component regulatory system. So here is another example that if you can reduce the amount of branched-chain fatty acids in Staph aureus, it can synthesize the toxins, but it cannot excrete those toxins. While we were drafting the observations that we had about that two-component regulatory system, a scientific group reached out to me because they had created this N315D8 strain. N315 is a methicillin-resistant Staph aureus strain. And by growing that methicillin-resistant Staph aureus, in the presence of increasing concentrations of daptomycin, they had created a very daptomycin-resistant Staph aureus strain. And daptomycin is probably one of the newest approved antibiotic for Staph aureus. If we find Staph aureus resistance even to daptomycin, there is very limited option that we have to treat Staph aureus infection. So when they created this Staph aureus daptomycin-resistant strain, they completely sequenced the genome of this strain. They found multiple mutations. But in terms of phenotypic differences in this strain, D8 compared to its parent 315, they found 2 things. One, it was growing very, very slow, and it had very high concentration of pyruvate dehydrogenase. It had very high concentration of branched-chain fatty acids, something that we witnessed with our PDS deficient strain. PDS deficient strain did grow very slow because of the reduction in Krebs cycle and also produced very high amount of branched-chain fatty acids. So we thought that maybe in this D8 strain, the BKD enzyme was overly functional or the pyruvate dehydrogenase was not at all functional. So we did some real-time assays and we found out that the expression of the genes responsible for the BKD enzyme, there was no change in the expression of those BKD genes. But the expression of genes responsible for pyruvate dehydrogenase was severely suppressed. So we found one clue why that D8 strain was producing more of the branched-chain fatty acids. So we thought that maybe like if we put more active pyruvate dehydrogenase in that D8 strain, we can restore the daptomycin sensitivity. That did not happen. We also could not basically restore the growth of that D8 strain when we put the more functional pyruvate dehydrogenase in that D8 strain. So here is how I will summarize basically the findings with this branched-chain fatty acid. A functional BKD enzyme is required, is needed for the synthesis of branched-chain fatty acids. When there is a reduction in the amount of branched-chain fatty acid in the Staph aureus membrane, it becomes very sensitive to like in vitro like conditions and also in vivo conditions. An active BKD or the adequate amount of branched-chain fatty acids is also needed for the excretion of the bacterial toxins from the cells. And maybe like this BCFA level is also required for the functioning of the membrane-acting antibiotics. So with all these findings, what I basically conclude is that the level of branched-chain fatty acids or the functional activity of the BKD enzyme can be like an attractive target to cure Staph aureus infections. So thank you again. I'm again very honored to be here, and I will take any question that you may have from this presentation.
We have any antibiotic which target BKD?
That will be the ideal goal. If I can find one, I can be very rich. So no, I don't have one.
What are the inhibitors of BKD?
We have not tested anything yet. I don't think that there is much available in the literature what can inhibit it. Because most of the studies have been done with like bacterium like Staph aureus. More of the early studies was done with Listeria monocytogenes, which is like a bacterial pathogen that can grow in the refrigerator. So that's where this enzyme cluster was first identified. And I took the information from there and studied that system in Staph aureus. But I have not found anything really that inhibits the activity of this enzyme. But that will be like very novel approach if we can find the inhibitors for this enzyme. It's in the chromosome. Because that's a very good point. Like that has been, if we can find inhibitor, then we can include that in many of the antiseptics that we use, like clean the like benches, the instruments. So we can inhibit pathogens like Staph aureus.
Resistance to this latest antibiotic that you were saying, to another mechanism of resistance.
Okay, so you mean the daptomycin resistance? So that's in 2022, we got like a funding from National Institutes of Health to study that. Right now, we know all the genetic mutations that have occurred in the D8 strain. Now we have to do some genetic experiments to figure out which of those mutations are actually responsible for that resistance. So we do not, that's a very valid point, and we are trying to find an answer for that. So we are in early stages to get an answer for that. So that we have already done. We know every gene that has been mutated. So we are going step by step, like we are trying to bring the functional gene back in that D8 strain, like I complemented with pyruvate dehydrogenase. There are other genes like another 2-component regulatory system, another gene PGSA. So there are, so like we have identified like 34, 35 different gene mutations.
But the antibiotic resistance genes, they do fall under a category. So could you find any such target genes from your results?
We have focused like the daptomycin, which is like if you think about the enzymes that target the cell wall synthesis, there is already so much done about that. So the daptomycin is the first of its own category of antibiotics that targets the bacterial cell membrane. So there is not much that we know of.
Actually, why I'm asking is because this is also about the omics thing. So, and omics is being largely used to discover novel antibiotic resistant genes.
Mm-hmm.
So, what would you comment on that? How useful has that been for you? Discovering and novel antibiotic resistant genes from the omics.
You know, like when you think about the antibiotic resistance, that area is the bacterium like Staph aureus, it replicates every 20 minutes. Compared to humans that replicate like every 25 years. They are so far ahead. No matter what we bring in, they develop resistance in 2-3 years. And you just go into the history of Staph aureus. We brought penicillin, it developed resistance in 2 years. We brought methicillin, we brought vancomycin. So it's just like how quickly they create mutations. And also the crosstalk, we talk about the microbiome these days. So much interaction between the different microbial communities, the genetic exchange, the genetic transfer, it's so rapid, it's so quick that like it's hard to find an answer. I get very pessimistic how fast they become resistant.
Okay, thank you. I so I'll be discussing again. So thank you. This is chairman of this committee. I should seek out will see myself. So this is something I will see that will see. Thank you. Thank you. So next, Dr. Joe, I request Dr. Joe, please come on with that.
Okay. So, good morning, everyone. It's my pleasure to be here after 18 years. Before I start, I would like to express my gratitude to the faculty of Biochemistry Division. Many of them are here. Dr. Bhaskar Sharma, Dr. Joshi, Mohini ma'am, P.K. Gupta sir. They provided me with the best mentorship, and I'm really thankful to them. And not to mention Dr. Nizamuddin Ahmed, late. He was my mentor when I was in the division, and he supported me. He wrote letters or recommendations. I still remember that I used credit cards from Dr. Joshi and Dr. Bhaskar Sharma to put in applications, and they just gave me their credit cards at that time. So I'm really thankful to them for all they did for my success. So the topic of my talk is multi-omics approach to identify molecular pathways of environmental health diseases. And the focus is ozone. Ozone is a gas which is a significant One Health challenge. It's a very highly reactive oxidant gas, and it causes respiratory health hazard, and it's commonly present in the environment. So in the ground level, ozone is generated by a photochemical reaction between the oxides of nitrogen and volatile organic hydrocarbons that comes out of the automobiles and combustion-driven industrial processes. And the inhalation of ozone polluted air is injurious to humans as well as to animals. And therefore, exposure to ozone can result in the significant increase in the hospitalization. So my research is mostly focused on understanding how ozone causes the initiation of lung diseases, or how do they interact with the other lung diseases like allergic asthma or COPD or cystic fibrosis. And the aim of this study is to use the multi-omic approach to understand how this disease is established and it progresses. And two sub-aims are to identify compartment-specific gene signatures that are relevant to the ozone-induced lung diseases, and also to identify exosome bounds, protein signatures in the air spaces of ozone-exposed lungs. So to accomplish this, we expose adult male and female mice to ozone at the concentration of 0.8 ppm or as a control to air. We expose mice daily for 5 days, 4 hours per night, and then wait for 2 days, and 5 days on, 2 days off, 4 days on. And then we perform the necropsies, and we collect the tissues, and then we lavage these mice, and we collect bronchoalveolar lavage fluids. And the goal is to assess the lung injury and to determine the gene expression in the compartment-specific manners, and to analyze the level of soluble and exosome proteins in the bronchoalveolar lavage fluid. So, as I said, ozone is an oxidant gas. It causes a lot of lung injury. So this data depict the levels of protein and where various inflammatory cells in the bowel fluid, and in the males as females. And we can see here that upon ozone exposure, the protein levels as well as the total cells
and macrophages, neutrophils, eosinophils, and lymphocytes, they are upregulated. So clearly, ozone is causing significant disturbance in the lung homeostasis. And then we perform, to get a deeper look into the pathogenesis, we perform a transcriptomic analysis. So this cartoon represents the lung, and we have the airways here, and this is the lung, where we have the airways and the alveolar spaces. And we lavaged these mice, and we collected the macrophages from the valve. We purified them. And then and we also collected the sections that were outside the lung lobes. These are called extrapulmonary airways. And when we collected this region, which is called parenchyma. So we focused on the transcriptomic analysis on these three different tissues or compartments. So it is not so easy to look into this heat map here. So this heat map represents all the genes that are known to influence the lung disease in humans as well as in animals. So this is one health approach, like, looking at the genes that are relevant to the humans and looking at them in the mice. And we looked at all of these genes and asked how they're behaving in different compartments in ozone-exposed mice versus air-exposed mice. And just to focus here, so this region is the parenchyma. We are comparing air-exposed mice with the ozone-exposed mice. And then you can see the ozone-exposed mice has the higher expression of the genes that were relevant to the lung disease in the humans. Okay, and then we saw similar trend in the tissue from the airways and somewhat similar in the macrophages. So this is the only data I'm going to show from the transcriptomic analysis. We have mountain of data that was published recently in AJP Lung. And then we looked at the soluble protein mediators in the bath fluid. And we found that all the chemokines that are responsible for bringing in all these inflammatory cells into the lungs, for example, KC or GCSF or IL-6, they were significantly upregulated in the ozone-exposed mice. And the trend was similar in the males as well as females. So then we got interested into looking at the level of expression or the enrichment of proteins in the exosomes. Now, what are the exosomes? So exosomes are extracellular vesicles that are within the range of 40 to 160 nanometer in size. So how they're formed? So their biogenesis starts with the invagination of the plasma membrane. So when this region is being invaginated, all those proteins that were being exposed to the extracellular region, so they are now being internalized. So if we follow this vesicle and we look at that, and eventually this vesicle will be forming multivesicular bodies. So basically all this entire vesicle is now disrupted into smaller vesicles. And this multivesicular body can then go back and bind to the plasma membrane and expel all these small vesicles. Now these vesicles will behave just like, or the protein on these vesicles will behave just like they would behave when they were on the plasma membrane. So the good thing is for the smaller vesicle is they can walk around, they can easily squeeze into the extracellular matrix and to facilitate the communication. So, so this cartoon tells like what are the different kind of proteins that are present in these vesicles and what are their function. For example, the proteins that are important for immunomodulation, or the proteins that will be important for the antigen presentation. And within these vesicles are proteins or RNAs, various species of RNA like mRNA or microRNA, and then the DNA and amino acid and metabolites. And what is their relevance? Their relevance is the cell-cell communication. It's known that these exosomes, that are coming from the B cells or different epithelial cells in the lungs, they can modulate the inflammation in the surrounding cells. They can activate them or they can immunosuppress them. And then another relevance is in the diagnostic purpose. So it's known that microRNA that is related with asthma or COPD or IPF, they are prevalent in the exosomes that are coming from the human bulk samples. Similarly, plasma-derived exosomes containing proteins, they can also tell like whether there is any kind of tumor progression going on. So we exposed animals. We looked at the exosomes. So in the bulk, so we took the bulk, we did the differential centrifugation, we collect the bulk proteins, and these are the exosomes, and then we subjected them to the LC-MS analysis to look at the protein enrichment in them. And we found that the exosome contents in the proteins, they were higher in the ozone-exposed mice. And then these proteins were enriched with the markers for exosomes. So telling that these exosomes are actually indeed exosomes because they're expressing all those protein markers. So then, just like we looked at the gene expression, we looked at the protein enrichment for all those proteins that are relevant to the human lung diseases. And then we were able to find that a bunch of those proteins, they were also enriched in the exosomes that were coming from the mice that were exposed to ozone. So then we had two different set of omics data, transcriptomics and the proteomics. Then we asked simple question, can we integrate this data and to see what are the cell types that are producing these different exosomes? So then we looked at around 600 proteins that were only enriched in the ozone-exposed mice. And we looked at those genes and we looked at corresponding mRNAs, and we asked whether this increase is paralleling the increase in any tissue 1, 2, or 3. We found that 180 proteins that were higher in the bulk, their corresponding mRNAs were increased in expression in all those 3 tissues. And for example, here there were 60 proteins that were present in the bulk, but their mRNA was only overexpressed in the macrophages. This would suggest that these proteins were being secreted by macrophages. Okay, so this is how we can integrate the data set coming from 2 different tissues and get to the meaningful endpoints. So now I'm going to switch gears and I'm going to talk about the microRNA, because I did mention that microRNAs are also present in the exosomes. So what are microRNAs? So microRNAs, they play a role in the post-transcriptional regulation. So microRNAs are secreted from microRNA genes in the form of primary mRNA, microRNA, and then under the influence of DROSHA and the other binding proteins, these pre-microRNA are converted into that is precursor mRNAs, and then after they come out of the nucleus into the cytoplasm, the pre-microRNA are processed by the dicer complex to release the microRNAs. So these microRNAs, they can bind to the mRNAs, and then they can target them to stay dormant, or they can target their degradation. So this is similar to what Dr. Dees Singh was mentioning, like, how these moieties or these different genetic molecules can affect the expression of the other genetic molecules. So then, and then listening to what Dr. Dutt was mentioning, that to foster cross-disciplinary collaboration and the international collaboration. So this is the data that was produced by one of the other lab, and they were also interested in the microRNA omics in the mice that were acutely exposed to ozone. Remember the way we expose mice, we expose them chronically. And this group was interesting in exposing mice to in just one time acutely. And they exposed their mice to the filtered air or 1 ppm of ozone and 3 ppm ozone. And then in the valve, they looked at various microRNAs. And you can look at it like some of the microRNAs were overexpressed, but others were suppressed. So clearly ozone was affecting the expression of microRNA in the exosomes. Now what they were doing there? So they looked at one of the microRNA MIR22-3P, and as they behaved in the heat lab, their expression was significantly higher at 2 ppm as compared to 1 ppm versus filtered air. So now this microRNA is known to target mRNA for a gene called BTP1. Okay. So parallel to increase in the microRNA, the mRNA was found to be decreased. So now just like this gene, there are 6 other genes that are also known target for this microRNA. And then we're looking at this data, we ask simple question, how are these genes doing in the data that we generated in chronic study? And we looked at those genes in the 2 different tissue, macrophages and the parenchyma, and we were able to see that many of these genes were suppressed in the chronic model also. So regardless of the information we got, it was from the acute study, but that was fully applicable here in the acute studies. So with this, I want to conclude here that multi-omics is a critical tool that can be used for the thorough investigation of complex disease pathogenesis. And then integration of omics data is essential. We cannot really drive conclusion based on transcriptomics data or just omics data, the proteomics data or lipidomics. We really have to have a system or pipeline to integrate the data and to connect the dots, whether it's making any sense or not in terms of the disease process. And all these molecular signature, they can be used as therapeutic targets and diagnostic targets. With this, I would like to conclude by thanking my lab members. And most of this data that I presented produced by Ishita Chaudhary and Thao. And then I'm thankful to my collaborators from different places. And I'm thankful to the funding that I have to conclude this research. Yes, so especially when you are in the hot summer months, and then your car is still running and you're waiting for the traffic jam to relax, that's the time when we will be exposed to ozone, because the tailpipe and the exhaust pipe is throwing all this nitrogen oxides and then volatile hydrocarbons, and that's when we can get exposed to ozone. Sorry? Can you say it again, please? Yeah, so there are some proteins like mucins, like MUC5B, MUC5AC. So these are gel-forming mucins. And when we are running through this cold and then all this phlegm that come out, that these are the mucins, gel-forming mucins. They were present in there, and there were markers for the macrophage specific activation. Yeah.
Have you matched your data with some of the COPD for asthma patients? Do you see any correlation between certain parties?
Yes, that's a great question. I'm sorry, I did not say it very clearly. All those 2 scary looking, very busy heat maps, they were driven using the genes that we shortlisted from the human data. So in terms of the gene expression or protein expression, yes, we have looked at grossly, like how those genes are doing in mice, but we haven't really run parallelly the samples in our lab to see how comparable they are. Yeah, that's a great question. So they're mostly so ozone actually parallel more to the allergic asthma rather than to the COPD.
I think that I may have discussed earlier. So now I request Dr. Dishita and Dr. Piril also please come on the last to participate. Dr. Yogesh. Then, Piril. Dr. Vinod Kumar Singh, Dr. Yogesh Singh, they are already education and chairman of the student of ACP, Dr. Mohish. So now I request Dr. Singh that this day, BTP division of biochemistry for one of this.
मां शाब्दिक नमन करते हुए मैं समारोह में उपस्थित सभी विद्वानों का हार्दिक अभिनंदन करता हूं and take this great opportunity being a division hosting this international conference and annual convention of the SVBI Society of Veterinary Biochemists and Biotechnologists of India. This is a very prime time. As whosoever present, this is time to pay my thanks and gratitude to all those who are present here. So in this regard, I like to first today's chief guest of the function. We all know that you have listened him also. That is very eminent scientist and distinguished biochemist, Dr. He has given his very keynote address to address all of us and given blessing for this conference. Thank you, sir, very much for this, your presence here. In this regard, and thanks once again to your conspirators and here so long 7 days journey. You are still in the journey, and I wish that you are being happy and you get a relaxation on your institute go. So, sir, this is the most things which today we are looking here. We are organizing this seminar and this convention. We know all the chief of and chief pattern as well as chairman of this function, and you know how that is the most venerable and pathfinder for us, our honorable director cum vice chancellor, most respected Dr. Timaidhaji. I also thanks for sir, your presence in this occasion. And so today this SVBI president on this dais, who has actually given a chance to here to organize this conference. So thanks for on behalf of our division as well as on the behalf of the IVRE family, and thank you for these things and secretary of this SVBI, Dr. Bhaktiyali, to team up for these things to be here from the so long distance, and we are given a 2 days this deliberation in this conference. On top of that, today is my guest, Dr. Most respected Dr. Nagen Sharma. You know that the family of IVR, and he is already has served as an ICR in different capacity. We all know as a director, vice chancellor, as well as he has served as a director of CRG in India. So he is here, and today we are very much thanks for him as well. As well here with Professor Emeritus Dr. Pradhan Singh, I am looking here, so he is here, but most respected here for the organization of a panel, the most respected joint directors. So
We are like to thank Dr. KP Singh is now here, but in some country he went off. Dr. SK Singh, most respected Dr. Research, he has given all the way our direction, supports in all the way. And Dr. Mediratta sir, he is not here though, but he sent a blessing to us and thankful for him. As well as and Dr. Uchi Tiwari, madam, he is here. I'm very much thankful to you being here and giving all the our joint directors time, I think last 1 year, all the way supports. And once again, I'd like to thank my place greetings and thanks to Dr. Rashid Singh sir who had taken all the pain for us that they were most of I'm seeing that we get registered and this and they are able to attend this conference. And today is the day, you know, all that the division of biochemistry going to celebrate golden jubilee year. So in this alumni of the biochemistry division, I am very grateful and I've got a opportunity to listen and I've seen very, very prestigious here, our great teacher, scientist who are now 2 or 3 weeks. I know him, Dr. P. Joshi, since last day. Yesterday he looking at us all the Baba boys and all, he's mentoring us even today, and he's so thankful for these things. And Dr. Ashok Kumar, most respected teacher and scientist who contributed in this. And Dr. Ivan Singh also, he has joined us. Thank you very much, sir, all of you, for being with us on this thing. The alumni of this biochemistry division, which is going to celebrating this annual convention as well as Golden Jubilee year on this day. I'd like to say this division has imparted continuously since last more than 50 years, this degree education and about 100 degree, doctorate degree and more than 150 degree postgraduate degree program has been given to all the students awarded have been awarded degree as well training the international national level in the field of biochemistry and the student who had now they are looking many responsibility in country as well as abroad. As I listened recently just now, Dr. Vinay Singh, you know that he is a student of alumni of this in this division, and Dr. Sani, which we have just now listened to Sani, sir. Here also is from here. So they have to lecture in relation there, how they are looking their responsibility on their different platform on this professional. So I'm very much thankful to you also. Very much thanks to taking pain from the USA and traveling and consulted us. And one more thing is my batchmate, Dr. Vinay Singh, we are both together joined ERA services on same day and in now. So I'm very much happy to be here in this location. My all the head of division, which are my colleagues, seniors who are here, really they have always supported us. They have given thanks. I'm seeing our some head of divisions who have given supports for this division for organizing this conference, international conference and the convention by this institute. As well as we know that in the Prashasan administration, that Dr. Neeraj is not here. I think he was here. I think more than 2 hours he was here. His team, finance also from all his team members, and most least. Okay, let me also continue, please. Thanks for Dr. Sharma, chairman and key member of society, AO from Assam. Morning I met sir, but I recently also joined. Like you are more senior here, but I joined this division. I met you morning to you. Thank you for me. Thank you for the us for you have sparing time from the so last distance. I like to most important thing which actually I like to share the purpose for this conference organized the delegates which come across the country and really I thanks apply to you all of you that most of all this alumni of the division also and most of I know I get students from my also students from so many across the country. So thank you very much for being here and being able to many exchange programs. The purpose of this conference we all know. This is actually now era and time has come. Very, very simple things. The understanding the chemistry of life, then it is the biochemistry. If you understand the function of the cell, if you not understand the function of cell, you cannot anything to go from the biological sciences or any branch is irrespective. This is a key role, as our director sir has told, and Dr. P. Singh, our most chief guest, also narrated. This is the science subject by which we can only know the function of cells of living beings, and then only you can interpret and modulate any plants, any things which we desired for today. That's why we put it the One Health multi-omics to One Health. The multi-omics is nothing. I like to again I'm paying my gratitude to those who had designed this conference theme. So this is also one of the very optimistic and today demand this conference theme, and that we can all know that thing. We don't know the genome, and how we can genomics. We don't know the transcription, how we can go transcriptomics. How we don't know the expression, then how we can go for the proteomics. Or many things now have changed. Bioinformatics. This is also the thing. So I'd like to say from this platform to all of you that paying the gratitude to those who have given us chance to share this knowledge in bioinformatics, genomics, nutrigenomics, as well as computational biology, which is now era of science where we can integrate all these omics, and then we can output, we can transform something for as a product for the ultimate we are working for that. That is for society, that is for the health and productivity of the animal, which can be ultimately become able to transfer every shorter time. So this is I am paying the gratitude to all those who are present here and they are participating in this conference for this thing. All those participants who are here present, who's not present here, all the thanks for this thing. But my division, I like also my responsibility that I day and night, all the students, all the employees, and my seniors start from Dr. Moni Seni to all the scientists of the division, Dr. Manish here. I think all we have working, but I don't know how long you will be the judge for us. But we tried our level best to have organized this type of one event, and then we can level to give a platform to the all academicians, researchers, students, as well as entrepreneurs to change their view, and then we will come out something fruitful to deliver for the society. Thank you very much to all of you, and please forgive me if somebody forgets the name of this thing. And thank you very much to all of you. Thanks very much.
Thank you, sir. Thank you all for making this program a success. It is indeed a golden opportunity for each one of us to enrich and enlighten ourselves. Now, let's conclude the program with National Anthem. I request the gathering to please rise for the National Anthem. As we disperse, I invite you all to join for a high tea, which is arranged in the lawn near the central auditorium. The tea break will be followed by 2 technical sessions. So I request all of you to join for the technical session after 10 minutes. The first technical session will be in the central auditorium, and the second technical session will be in the committee room of administrative building. Have a great day.